subject name is design of concrete structures. So here, this is your first semester, and as your examination scheme is your theory paper is of 100 marks and term work is of 25 marks. So out of that 100 marks, your ISC is for 30 marks and ESC is for 70. So basically, what I want to tell you, the design of concrete structures one. This is one of the most important subject because it involves the design of slab, design of beams, design of columns, then design of footings, design of staircases, so singly and doubly reinforced sections, T beams, L beams, then design for torsion. All these things you are going to study in this subject. So for that, now see, although it is online teaching, PPT presentation is there, still I am going to dictate you the important points and you must note down that points in your notebook. Why I am telling you these things? Because these important points are very useful for you in the point of view of examination. Okay, so be ready with your notebook as well as with the calculator. We have to solve some problems. We have to check whether the value showing in the PPT, are you getting the same value or different value. And also yesterday I have sent you the IS code to your mail as well as on the WhatsApp group. So I hope you have downloaded that, and side by side we have to look in the IS code also. So IS code means Indian Standard Code. You might be knowing that an important clause related to design it is given. It is like what we can say this भारताचं संविधान आहे ना, तसं it is like design संविधान like that. Okay, we have to use the clauses whatever given in the IS code for the design purpose. So basically now, what is the meaning of this word design? Okay, we must see what is the meaning of this word design. So design means what? We are going to decide the dimension of a member. Okay, then what must be the dimension of a member? Suppose now I am designing a home. Let us say 1 BHK home is I am going to design, and now I am casting the plinth beam, or now I want to design the plinth beam. Then what should be the size of that plinth beam? That comes under the design. So in design, first of all, we decide what is the size of the member. Then in design, we decide how many numbers of steel or steel bars we need to provide in the given section. As you are knowing very well that any member is comprising of at least two things, that is concrete and steel. Okay, so once you decide the size of the member, then you are automatically deciding the quantity of concrete. And once you find out what is the quantity of steel required, that is the number of bars, then you will get the design of steel, that is number of bars, that is quantity of steel. Okay, so in this way we are going to calculate the quantity of concrete, quantity of steel, that is design of our plain beam including steel. So basically design of concrete structures once is the subject which is related to design. So now we will come to the syllabus. This is the little bit introduction of this structure. So as you know, civil engineering is very vast. Some structures which are there, water tank is also there. That is not included in your syllabus right now. In DCS 2, you will learn how to design the water tank. So retaining walls are there. Then silos are there. Bunkers are there. High-rise towers are there. Okay, so high-rise towers are comes under steel structures. So these you need to design, and be clear with one thing: whatever design we are going to learn over here, it is only and only by limit state method. I hope I clear to you. I will tell you what are the design methods, what are the different methods, then why limit state method is used. We will come to this introductory part later on, but right now you just remember that while designing any structure or any civil engineering component, we are going to use limit state method. Okay. So now here, as I have told you, what is your examination scheme, theory paper, term work mark. So now course objective. Okay. So the course objective, our first course objective is to understand the concept of working stress and limit state method. Second course objective is to gain the knowledge of limit state design for flexure, shear, bond and anchorage. This is the most important thing. Okay. So to gain the knowledge of limit state design for flexure. Flexure means it is for bending. The flexure means bending. Shear, you already know what is shear force, what is shear. So further we are going to learn what is one-way shear, what is two-way shear in this. Then bond means the bonding force between steel and concrete, and the anchorage. And the last one is the to understand the behavior of column subjected to eccentric load and use of interaction diagram. Okay. So last objective is to understand the behavior of column. So basically we are going to design the column for axial as well as eccentric loads. Okay, so we will move to the next slide. So here the syllabus is unit number 1, that is introduction. So here philosophies of design and their relative advantages, disadvantages and classification of limit states, characteristic strength, characteristics load, load factor, partial safety factor, limit state of serviceability and IS code recommendation. These are the pointers which included in your first unit introduction. So here in the first unit, uh, in the exam from exam point of view, the first unit is important only for the MCQ questions. Okay, MCQ questions may be asked you in the examination based on this first unit, but the theory question will not come from the first unit. Okay, because as this is a design subject, the question in the examinations are like that: design the slab, design the beam, and so on. Okay, so this first unit is only good for MCQs. So we will see each term one by one later on. Right now we are going to the overview of this syllabus. So here in the first introduction, I am going to tell you there are basically three types of design procedures. Listen it very carefully because uh, this is the first time you are facing this working. The three methods are: first is the working stress method, the second is the ultimate stress method, and third is the limit state method. Okay, so working stress method is having its own limitations. Then ultimate stress method is also having its own limitations. That is why right now in the market, or we prefer limit state design method, which is most likely the combination of working stress as well as ultimate stress. Okay, so basically, how many types of design methods are there? Three types of design methods are there. First is working stress, second is ultimate stress, and third is limit stress. Okay, so now in India and all over the world, almost limit state method is used for the design purpose. So later on, we will see what is working stress method, what is your ultimate stress, and what is limit stress. Then after that, in this first unit introduction, the classification of limit state. So we are going to study the limit state method is further divided into two major parts: limit state of collapse and limit state of serviceability. During the unit, we will see that what is limit state of collapse and what is limit state of serviceability. Next point is characteristic strength and characteristics load. So characteristic strength and characteristics load. So you might be knowing this. Okay, you might be knowing this. What is the characteristic strength and what is the characteristics load? So uh, I will tell you once again what is the characteristics load. Suppose now, or strength. Suppose now, if you cast a number of cubes. Okay, suppose you cast 100 cubes, which is having a size of 15 by 15 by 15. Okay, that is 150 mm by 150 mm by 150 mm, or 15 centimeter by 15 centimeter by 15 centimeter. And you break all these cubes on a CTM machine. Okay, compression testing machine. If you break all these cubes, then characteristic strength. So characteristic strength is the nothing but if you break all these 100 cubes on a CTM machine, so 95 cubes and above cubes shows you the strength. If the concrete cubes are made up of M20 grade, then above 95 cubes must shows the strength of M20. That is the meaning of characteristic strength. Am I clear? I will tell you once again. If you cast say around about 100 cube, which is of a size of normal standard size 150 mm, 150 mm, 150 mm, and if you break all these cubes on concrete testing machine, compression testing machine CTM, then 95 cubes or more than 95 cubes should give you the result of strength 20 Newton per mm square. Then we can say that this 20 Newton per mm square is nothing but the characteristic strength of the concrete. Okay, and the load corresponds to this characteristic strength is known as the characteristic load. Okay, so this is the basic introduction of characteristic strength and characteristic load. So after that, we will move forward to this partial safety factors. So in limit state method, there are two partial safety factors. First is for concrete and second is for steel. So two different partial safety factors are used for concrete and steel. For concrete, normally it is used as a 1.5. For steel, normally it is taken as 1.15. Then next is the limit state of serviceability. Okay, so this comes under this classification of limit state. This is the part of this limit state of serviceability. This we will see in detail when we are going through this chapter. And what are the IS code recommendations, that also we will see later. Okay, so this is the brief introduction about your unit number 1, introduction. Now, if we move further, then here is unit number 2, design of slabs. Okay, design of slabs, and here you can see it is given as limit state method, design of slabs by limit state method. So the contents are one-way slab, one-way continuous slab, two-way slabs with different end conditions as per IS code, cantilever slab. So these types of slabs, how many types of slabs are there? 1, 2, 3 and 4. So one-way slab, one-way continuous, two-way slab and cantilever slab. So there are 4 different types of slabs are there for your syllabus. So in the exam, 100% there will be a question to design a slab. Okay, out of these 4, any slab can be asked in the exam. Normally, the design of cantilever slab is very easy, so they did not go for the asking the design of cantilever slab, but still we are going to see all the slabs. Okay, so now next is of slab. IS code is needed for us while designing the slab. We have to decide first what is we will have to see what is one-way slab, what is two-way slab. Okay, what is main steel? The terms you will come across: main steel, distribution steel. What are the different end conditions? So if you gone through the IS code in table number 26 and table number 27, different conditions for designing of the slabs are given, different coefficients to calculate the bending moment are given. So based on that, we are going to design the slab. So design of slab means what? Basically, what we are doing in designing of the slab, we will assume certain depth of the slab. Okay, first of all, if we want to design the slab, we will assume the depth. We don't know what is the depth of the slab initially. So we will assume that. Later on, we will calculate what is the load acting on the slab. From that load, we will calculate the bending moment. After the calculation of bending moment, we will cross verify that whatever depth we have assumed initially, that depth is sufficient to withstand for this bending moment or not. That we will take the check. If this check is satisfied, then further we will calculate what is the amount of steel required, and last part is we will draw the reinforcement details. Reinforcement details means a section of slab or a sketch which shows the how many bars are provided, which bar is moving from which point to which point, what is the starting point to end point. So in that way we have to do the design of slabs. So for different methods are there for different types of slabs. So those methods we will see in the detail while going through this chapter, that is design of slabs. Uh, then the unit number 3 is limit state of collapse, flexure, shear and bond. Okay, so limit state of collapse, this is the name of the unit, but actually in this unit we are going to see the analysis and design of singly and doubly reinforced rectangular sections. Okay, so here I will uh, see that, you can see that here singly and doubly rectangular sections. Here only we are going to see the rectangular sections. Now we will see what is the meaning of this word singly and what is the meaning of this word doubly. So singly reinforced sections means what? I will give you just a little introduction. Now if you see any beam, in that beam, most of the times at the bottom of the beam, 3 or 4 steel bars are placed, not more than that. Three steel bars are placed, and if you see at the top level, at the top, 2 bars are placed. Okay, that 2 bars are maybe of 10 mm diameter. It is placed, and after that, the stirrups are bound around those bars. Stirrups means in Marathi, if we say in simple words, then ringa. On site, it is called as rings. Okay, and in labor language, it is called as ringa. ते लेबर लोक सगळे त्याला रिंगा म्हणतात. So those are nothing but stirrups. We call technically as an engineer, we call this as a stirrup. So singly reinforced sections means what? Those the bottom bars which we are going to place in the beam. So for that bottom bars, we have calculate what is the bending moment at the bottom of the beam. And based on that bending moment at the bottom, we are going to provide the steel bars. So we are not going to design for the topmost bar. We are going for to design only for the bottom bar. So these type of sections are called as singly reinforced sections. And next is the doubly reinforced sections. So for doubly reinforced sections, we are going to provide the steel at bottom as well as at top. Okay, so at top and at bottom means what? Now you imagine a rectangular section. You imagine the centroid of the rectangular section. From the centroid past the horizontal axis. That axis is nothing but our neutral axis. You know what is the neutral axis as you have studied in the second year already. Every fiber on the neutral axis or every molecule on the neutral axis does not experience any stress or force. It is that is why it is called as a neutral axis. So the elements above the neutral axis are generally goes into the compression, and the fibers or molecules below the neutral axis are generally goes into the tension. So in the case of the doubly reinforced section, what happens? We design the steel at bottom. Okay, so we calculate the bending moment and we provide the steel at bottom, as well as we design what is the amount of steel required at the top in compression zone also. What is the quantity of steel required in compression zone? So these types of sections are called as doubly reinforced section. So I will give you one example of doubly reinforced section. If you see the bridge girders, okay, huge girders. ब्रिजला काय असतं की आपण we called in a residential building beam, the horizontal member, we call that horizontal structural member is beam. But in the case of bridges, those beams are quite large and having very big sections. So these beams are called as girders. Okay, girders, girders. So these girders carries the steel at top as well as steel at bottom, and these types of sections are called as doubly reinforced sections. Why it is doubly reinforced sections? Because you cannot define what type of stress actually coming on that structure. I mean, sometimes due to the live load or moving traffic load, it happens that initially suppose the compression is at top and tension is at bottom, but due to this moving traffic load, it may happen that tension will create at top and compression may be created at bottom. So there will be the reversal of stresses happening here. So to resist these types of situations, if the reversal of stresses comes in the picture, then the section will fail miserably. It will fail very early. So to avoid this type of situation and to withstand the structure, even though in the reversal stress condition, we always design the doubly reinforced rectangular section. Okay. Also, whenever there is a depth restriction, now if you go in the apartment, you see that mostly in the apartment the basement is given for the parking, and if you observe the parking beams very keenly, then you notice one point that the depth of each beam is almost same, or it is designed in such a way that the depth of the each beam is always same. Okay, so in such a cases, now if the depth is same, if you want to keep the depth of each beam, it is equal, but the load coming on each beam is not equal. The load coming on each beam is different, but still you have to manage that, you have to keep the depth of all the beams in equal. Then in such a cases, when you reduce the depth, then you have to place some additional steel at top. Okay, at top means at compression zone above the neutral axis, and you need to design that steel. How many numbers of bars are required? So the bar diameter maybe it is of 10 mm or 12 mm. So that we will see how to design it. But basically understand under these types of situations we may go for doubly reinforced section. Okay. So now this is the brief introduction of limit state of collapse. That is your unit number 3. Then here we will move to the next unit, that is unit number 4. Here you are going to design the flange sections. Flange sections means what? Analysis and design of singly and doubly reinforced T and L beams for flexure. Flexure means for bending. Okay, so here we are going to analyze and design the T and L beams. So T and L beams, you might be thinking that, oh, I have not seen in the building any beam like a T shape which is having T cross section or which is having L cross section. So it is not like that. We are going to design a rectangular beam only, but there is a T action happening in that rectangular beam. That is why we call that rectangular beam as a T beam. So now if you observe any building or any structure, that is our residential building or any RCC structures, so there is not a T, you will not observe any T beam. You will not see that a beam is having cross section which is of T shape, or you will not see a beam which is having a cross section of L shape. Okay, so for that there are T and L actions are there. So what is T action? What is L action? Why it is called as T beam? Why the beam is a rectangular beam, but although it is called as a T beam? Why the given beam is rectangular beam, but although it is called as L beam? Those details we are going to study in this unit number 4. Okay, so on the unit number 4, there will be definitely one question in the exam that design this and this T beam for this and this given data. From unit number 3 also there will be one definitely there will be one question is there in the exam. Design this and this singly reinforced section or doubly reinforced section likewise. Okay, now this ends your section 1. So totally I think 4 units are there in section 1. So we will move to the second section, section number 2. So here your unit number 5, design of continuous beam. So design of continuous beams means what? Up till now what we have learned. So here I want to remind you one thing. You need to be very clear with the basic concepts of shear force and bending moment. In design, every time we are in the need to calculate what is the bending moment coming on the particular structure, and what is the shear force coming on that structure. Okay, so particularly in the case of these continuous beams, now you are knowing the formulas for simply supported beam. That general formulas we know what the simply supported beam is there, and if it carries a point load W anywhere on the beam at a distance small a from left end, at a distance small b from right end, and total length is L, then our bending moment will be WAB by L. Okay. Similarly, similarly, you know that for simply supported beam carrying UDL, if a simply supported beam is there and it is carrying UDL throughout the span, then you know the formula. What is the formula? It is WL square by 8. Similarly, you know for cantilever beam carrying point load UDL. So these are some formulas are there. Although these formulas are known to you, even though sometimes the situation may arises that you need to calculate the bending moment at a particular point, and when you come across this type of situation that we need to calculate the bending moment at a particular point, then you must be clear with your basic concept. In that, you need to calculate the reaction first, then you have to take a section at a point where we need to calculate the bending moment, then consider either left hand side or either right hand side, and then by using our conventional sign conventions we need to calculate the bending moment. And similarly the same procedure is there for shear force, although the sign conventions are different. So please, today after this lecture, go through these basic concepts. Okay. So now, in the design of continuous beam, now, what do you mean by continuous beam? A beam which is having more than two spans is called as continuous beam generally. Okay. If a beam is having two or more spans, a beam must have at least two spans, or if greater than two spans are there, then it is called as a continuous beam. Okay, so we are going to design the continuous beam by limit state method. So as we see in the second unit in design of slab, there is one bit, design of one-way continuous slab. Okay, there is one bit, design of one-way continuous slab. So the procedure of designing of one-way continuous slab and designing of continuous beam is almost the same. So once you cleared that concept in the second unit in design of slab, how to design the continuous slab, if that concept is getting cleared in that unit itself, then this first unit, fifth unit is bonus for you. Then this fifth unit is bonus for you because the design steps are almost similar and the design is almost same. So that design we will see in detail later on when we will come across this chapter, that is design of continuous beam by limit state method. Then next unit is unit number 6, limit state of collapse. The limit state of collapse, that is torsion. So here the behavior of RC rectangular section subjected to torsion, design of sections subjected to combined bending and torsion, combined shear and torsion, design of beams for torsion. So this is the syllabus given to you here. But here, if you observe what they have given that the beams or sections subjected to combined bending and torsion, and then combined shear and torsion. But listen carefully. But in the exam, you got the problem. You will get the problem, which is comprising of all these three, which is comprising of shear as well as bending as well as torsion. Okay, shear, bending and torsion. So we will see such a problem that which in that problem they ask us to design the sections, and they told us they are combinedly affected by bending as well as torsion and as well as shear. So this type of problem, 100% this type of problem will be there in your question paper, in your exam. Okay, and this problem will be of 10 marks, 8 to 10 marks, I think so. So this is your sixth unit, limit state of collapse. So torsion means twisting movement. Okay, you have already know the formula for torsion. You have gone through the torsional equation. What is the torsional equation? It is T by I is equal to tau by J is equal to C theta by L. Am I right? So this is the torsion equation. So you already know what is the term torsion. Whenever there is a twisting movement across the section, then torsion will be there. The another name for torsion is twisting movement. The twisting movement and torsion is one and the same thing. So we will see how the rectangular section behaves when it is subjected to torsion, bending, and shear. Okay. So when we come to this chapter, then we will see this in detail. Now this is brief introduction for this. Now last one is the unit number 7, design of columns. So now in the sorry in the seventh unit, that is design of column, we are going to see that analysis and design of axially and eccentrically loaded circular and rectangular column. So I hope now you are knowing the term axially loaded and eccentrically loaded. Now, as you see come across the term column, we imagine that a vertical member which carries the load, it is the column. Now, normally we define the column in that way also. If you see along the length of the column, if the load is acting exactly at the center of the column along the axis, then it is called as the axially loaded column. Okay, and if the load is not acting exactly on the axis of the column, but it is acting at some distance apart from the centroid or axis of the column, then it is called as eccentrically loaded column, because that load generates some eccentricity or eccentric movement on that column. And that eccentric movement, we know that if the vertical load is P and the distance from the centroid is E, then your movement will be P into E. So P into E will be the eccentric moment that came into the picture when the column is eccentrically loaded. One more thing I want to mention here: when the column is actually loaded, then you are getting direct stress as well as bending stress. Okay, so direct stress is nothing but direct stress, it is P by A, load divided by area, it is nothing but your direct stress, and bending stress, it is M by Z. Okay, so bending stress is nothing but it is M by Z. And in the case of eccentrically loaded column, you will get these two stresses. P by E is always there, that is direct stress is there, and bending stress is also there, M by Z. But along with that, you will get one additional stress due to this eccentric moment. Okay, and that stress, we call that stress as a stress due to eccentricity. And that stress is nothing but our basic formula for bending stress is M by Z. But here, the moment due to eccentricity, review of your syllabus, total 7 units are there, 4 units are there in first unit, then 3 units are there in second unit. Based on this, in these 7 units, almost all the design, that is slab is covered, then beams are covered, beams, that is rectangular section, then T section, L section, and after that your column, then continuous beam, then beam subjected to torsion. So all these things are covered over here. Presentation which I have started just now, is it visible to you? Hello?
Yes, sir, visible.
Okay, thank you. So now we will discuss about what is working stress method. Okay, so please remember this. In exam, there will not be any question regarding this working stress method. तुम्हाला एक्झाम मध्ये वर्किंग स्ट्रेस मेथड वरती काहीही विचारलं जाणार नाही. स्टील टू नो द बेस फॉर युअर अंडरस्टँडिंग, आय एम टेलिंग यू what is the working stress method. I will try to explain you with the help of these slides. Okay, now as you see over here, there is we have considered one cross section over here, cross section of a rectangular cross section. This is the width B and this is the overall depth is capital D, and this small d is nothing but effective depth. Okay, this small d is called as the effective depth. Now, what is the meaning of effective depth? Effective depth is the depth which is measured from top to the center of this reinforcement. That is center of this bar. From top to the, that is from top to the center of this bar up to this point. Whatever may be the depth of the section, that depth is called as the effective depth. Okay, and you will always observe one point, that whenever we place the number of bars in a beam or in any section, we left some place at the bottom. Okay, and that is called as cover. That is called as cover. We keep some space. We don't we never put these steel bars directly which is resting at the bottom. We keep some space in between, and that is called as a cover. And from bottom to the center of this bar, from bottom to the center of this bar, whatever may be the distance, that is called as effective cover. That is called as effective cover. So remember these things. From top, if you measure the depth up to the center of the reinforcement, then that is called as the effective depth. And from bottom, if you measure the distance up to the center of this reinforcement, then it is called as the effective cover. Now here you see that there is one axis shown over here. So this axis is called as a neutral axis. The axis which is passing through the centroid of the cross section is nothing but the neutral axis. So we assume that every fiber or every layer or every element, molecule, whatever you say, which is there, uh, which is there on this neutral axis, doesn't experience any stress. It doesn't undergo compression. It does not undergo tension. It is always neutral. So the elements or the layers above this neutral axis. So above this neutral axis at any general distance y, if I take any strip, then it is subjected to what? At any general distance y from this neutral axis, if I take the strip, then we will find that here the compressive stress exists. In this zone, the stress is compressive. Okay. And here below the neutral axis where we provide the steel, here the stress is the tensile stress, or below the neutral axis tensile stress is developed. Okay. So this neutral axis is at a distance of n from the top. Here the term is used as n. So as the effective depth is d, so this remaining distance will be, if this total is d, this is n, then this remaining will be d minus. And this is the typical stress distribution diagram across this cross section. So as I have told you earlier, in the topmost fibers compression force is, compressive stress is there. So the notation is sigma c. Okay, so it is also called as stress in concrete, compressive stress, sigma c. And here at the neutral axis at the center, the stress is 0. And after that at bottom, the tensile stress is there. So this is the distribution diagram, the tensile stress. You will see the difference in the direction of the arrow. Here the direction of the arrow from this point to this point. Okay, so it is from leftward to rightward. And here if you see the direction of the arrow, so it is from rightward to leftward. So this shows that these two stresses are opposite in nature. So if this stress is compressive, then this stress will be tensile. So this is the typical stress distribution diagram for working stress method. These types of stresses are developed in working stress method. So I will read some important points. Basically, I will tell you in 2 to 3 simple lines why this method is not adopted. You just remember why this method is not used now. It is adopted earlier, but why it is not used now? Whatever may be the assumptions made in this working stress method, or whatever the concepts are used in working stress method, they assume that the stress is directly proportional to strain, or the Hooke's law is obeyed by concrete and steel up to its breaking point. Are you getting my point? Up to its breaking point or point of collapse. So this method basically assumes that the steel and concrete always obeys the Hooke's law. That is, stress is directly proportional to strength. That is your Hooke's law. It always obeys by steel and concrete up to the point of collapse or point of breaking or point of failure. But in actual practice, it is not that, like it is not the case. You might be knowing that what is the stress strain curve for steel, what is the stress strain curve for concrete. Okay, so the stress strain curve for steel, it is always linear up to the certain point, and after you know that there is a limit of proportionality, then upper yield point, lower yield point, then ultimate stress point, ultimate load point, and afterwards failure is there. So if you see this graph, then for a particular portion there is a linear variation. The Hooke's law is obeyed, but after some point, Hooke's law is not obeyed by the material. But this working stress method entirely what it assumes that up to the breaking point or up to the collapse, the material is obeys Hooke's law. So but practically it does not happen. So it leads to larger sections. If you design the section by using working stress method approach, then the size of the section will be bigger. Okay, and also this assumption is not correct, not that much of correct. It will not give you the correct value of the working stress. It will not tell you the correct value. That is why this working stress method is not adopted now, and the designs are not carried out by the working stress method. Okay, so you open your notebook and write down this heading, working stress method, and draw this diagram. Yes.
सर एक डाऊट आहे की सर वर्किंग स्ट्रेस मेथड मध्ये तुम्ही म्हणताय की म्हणजे ब्रेक होईपर्यंत इलास्टिक लिमिट मध्ये असल्यासारखं आपण त्याला ट्रीट करतो.
करेक्ट.
हा मग मग जर तुमचं म्हणणं बरोबर असेल तर डिझाईन आपल्याला म्हणजे ही मिळायला पाहिजे ना, कमी मिळायला पाहिजे. तुम्ही म्हणता लार्जर डिझाईन मिळते.
Oh, larger design method. Why it is larger? Because Hooke's law what it says, if the stress is increased, then strain is also increased. Okay, that is stress upon strain, you are getting Young's modulus. But in limit state, कशामुळे कमी मिळतं माहिती का? लिमिट स्टेट मध्ये काय होतंय, लिमिट स्टेट इज हॅव्हिंग डिफरंट फॅक्टर ऑफ सेफ्टी फॉर डिफरंट टाइप्स ऑफ लोड्स, and limit state take into the account the actual stress which is present at the breaking point, which is not taken into the consideration while doing the design by working stress method.